We'll come to order. Good morning to all who've joined us here for this very important hearing. I'd like to make a short statement, and I'll turn to my good friend from Florida, Mr. Feeney, for his statement, and we'll begin the hearing. Today's hearing builds on the Science and Technology Committee's February 13th hearing, at which we examined the findings and recommendations of the National Academy's Earth Science and Applications Decadal Survey. The Decadal Survey represented a consensus of the earth sciences and applications community on what the earth science research priorities should be for the coming decade and identified a prioritized set of missions. It is an impressive report, and it provides a very useful set of benchmarks for Congress as we attempt to evaluate NASA's current and planned activities in earth science and applications. Today, we want to examine how well NASA's plans and programs compare to the priorities of the Decadal Survey and the extent to which NASA intends to support those priorities in the fiscal year 08 budget and beyond. As numerous witnesses before this committee have testified, the situation facing NASA's Earth Science program is not good. To quote the Decadal Survey, it first noted that the Decadal Survey's interim report had cautioned that the nation's system of environmental satellites was at risk of collapse. It then went on to state that in the short period since the publication of the interim report, budgetary constraints and programmatic difficulties at NASA have greatly exacerbated this concern. At a time of unprecedented need, the nation's Earth observation satellite programs, once the envy of the world, are in disarray. Those are troubling words, because NASA has a major role to play in the nation's and indeed the world's climate research efforts. If NASA doesn't step up to that role, the negative consequences of that failure of leadership will be long-lasting. I look forward to hearing from our NASA witness, Dr. Freilich, about what NASA is going to do to turn this worrisome situation around. And I hope that he will be able to provide some specifics on how NASA intends to implement the Decadal Survey's recommendations. In that regard, I'm also concerned about the fate of the climate instruments from NPOS and the need to ensure that we don't needlessly disrupt the instrument development activities while the administration is determining what will be done about them. I hope that the good doctor will be able to shed some light today on what interim arrangements are being put in place to preserve those instrument teams and development efforts. Finally, I think many of us in Congress are interested in ensuring that the Earth observations data being collected by NASA is applied wherever appropriate to societal needs. That's why I introduced the Remote Sensing Applications Act, which became Sections 313 and 314 of the NASA Authorization Act of 2005. It's not clear that NASA's efforts to date have been fully responsive to the intent of that legislation, and I look forward to working with the agency to make sure that the goals of the provisions can be realized. Well, we have a lot of issues to address today. I again want to welcome our witnesses, and I look forward to your testimony. At this time, it's my privilege to recognize Mr. Feeney for whatever statement he may have.
Well, thank you, Chairman Udall. This morning's hearing on NASA's Earth Science and Applications programs is the first held by our subcommittee on this important topic, and I'd like to begin by thanking our witnesses for taking time from their busy schedules to join us today. I realize a tremendous amount of time, effort, and preparation goes into appearances before congressional committees, and I want all of our witnesses to know this committee greatly appreciates your efforts and values your wisdom. Today's hearing on NASA's Earth Sciences and Applications programs and the FY08 budget request gives our committee an opportunity to review NASA's management of and rationale for its current array of Earth-observing missions and an opportunity to understand how the agency will incorporate the recommendations of the Earth Sciences Decadal Survey in its future plans. NASA's Earth Sciences program is one of that agency's unsung achievements. When discussing NASA, our nation's collective attention is often focused on human spaceflight or stunning images returned from distant planets and orbiting observatories. But rarely does the national press carry front-page stories or images from NASA's Earth-observing satellites, except perhaps during hurricane season. Having said that, most of the weather and climate prediction tools used daily by forecasters is often a direct product of NASA-sponsored research. And a good portion of climate change research is also made possible by data taken from NASA-developed sensors, satellites, and sophisticated research and analysis products. Will this record of accomplishment in Earth science missions continue? Yes. Will it happen fast enough to satisfy many of us and the research community? Probably not. Are NASA's plans for future Earth science research missions any indication of the agency's reduced commitment towards a robust program? Emphatically, no. NASA's other science programs, astrophysics, planetary, and heliophysics, share the same challenges as Earth science. Their related decadal surveys prioritize researcher wishes and offer strategic guidance on the types of sequence of missions needed to answer leading questions. NASA has neither the resources nor oftentimes the necessary technologies to fill all of its desires. But NASA does strive to fulfill the highest priorities established by the research community. Requests for expanded efforts in all NASA's fields of endeavor simply confirm this agency's reputation as a place where the most challenging tasks get done. Having said that, I hope we don't drift into an earlier era where NASA was tasked with doing too much with too little in the way of resources. We know where that path led. So I hope all NASA supporters, myself included, temper our enthusiastic desires with a realistic assessment of what's possible. NASA Earth Science Program has produced stunning scientific results, often demonstrating for the first time measurements and capabilities that have never before been accomplished. I want that record of achievement to continue, and it's also my desire that we build upon this program's success to enable the goals established in the decadal survey. Again, thank you, Chairman Udall, and thanks again to the witnesses.
I thank the gentleman from Florida. At this point, if there are members who wish to submit additional opening statements, your statements will be added to the record. Without objection, so ordered. At this time, I'd like to recognize Ms. Hooley, who's going to introduce the first witness, Dr. Freilich. Congresswoman Hooley.
Thank you, Mr. Chair. And I would like to thank not only you, but our ranking member Feeney for allowing me to participate today and the opportunity to introduce Dr. Michael Freilich. Dr. Freilich is the director of the Earth Science Division in the Science Mission Directorate at NASA headquarters. Prior to coming east to work for NASA, he was a professor and associate dean in the College of Oceanic and Atmospheric Sciences at Oregon State University, which is in my district. And I'm sure that he is just as proud as I am that the Oregon State University's men's baseball team just won its second national championship in many years. Dr. Freilich research focuses on the determination, validation, and geophysical analysis of ocean surface wind velocity measured by satellite-borne microwave radar and radiometer instruments. He has developed scatometer and altimeter wind model functions as well as innovative validation techniques for accurately quantifying the accuracy of spaceborne environmental measurements. Thank you, Dr. Freilich, for agreeing to testify before this committee. I'm sure the committee will benefit from your insights. And I would like to stay, but I have a markup in another committee going on at the same time, so I will have to leave. But we are so glad you're here, and thank you for coming.
I thank the gentlelady for that introduction, and I would like to at this time introduce the rest of the panelists. I'll start with Dr. Richard Anthes, who's appearing before this committee for the second time after testifying on the National Academy's Earth Science Decadal Survey back in February. We appreciate his willingness to participate in today's hearing. You all should know he's president of the University Corporation for Atmospheric Research, and I'm biased. It's always great to have another Coloradan here in the nation's capital. So, Doctor, thank you for making the trip here. Next to Dr. Anthes is Dr. Eric Barron, who's the Dean of the Jackson School of Geosciences at the University of Texas, Austin, and he was the chair of the Climate Variability and Change Panel of the Decadal Survey Committee. This is not his first appearance before this committee. Dr. Barron, thank you for being here today. And finally, we have Dr. Timothy Foresman, who is the president for the International Center for Remote Sensing Education and has long been involved in activities related to promoting the application of Earth science data to meet societal needs. Again, welcome. I think all of you know your pros. You've been here before, but we ask you to limit your spoken testimony to 5 minutes, and then after which we'll have an interchange in which members of the subcommittee will have 5 minutes each to ask questions. Dr. Freilich, we'll start with you. The floor is yours.
Thank you very much. Mr. Chairman and subcommittee members, thank you for the opportunity to discuss the President's FY 2008 budget request for NASA's Earth Science program. NASA is committed to Earth science, as am I. The budget request includes nearly $1.5 billion for Earth science, an increase of about $32 million over the FY 07 request. Our balanced program includes flight missions, research investigations, applied science, technology investments, and outreach programs. I'll focus my remaining oral comments on your specific questions. First, our top Earth science objectives and plans. Our primary objective is to advance Earth system science and to use this understanding efficiently to address societal issues. To reach this goal, we will, in priority order, first, reinvigorate the flight portfolio by building and launching 7 missions now under development and initiating new missions as recommended by the Decadal Survey. Second, we're working with NOAA and other agencies to hasten transition processes so that measurements pioneered and proved by NASA will be acquired by operational satellite systems over multi-decadal periods. And third, we will preserve and expand through competitive solicitations the preeminent research and analysis, applied sciences, technology development, and educational programs that distinguish the NASA Earth Science endeavor. The Decadal Survey provides specific guidance in these areas, and the President's 08 budget request advances us towards these objectives. You asked about balance in the Earth Sciences program. The program is nicely balanced between flight and research science activities, with almost half the total allocated to our 14 operating missions and the 7 missions in development, and the other half to research, applied sciences, data systems, technology development, and education programs. The Earth Science Subcommittee of the NASA Advisory Council annually examines the split of activities and assesses our scientific performance. Regarding mission size, all of the missions now in development and those recommended by the Decadal Survey are focused missions. We are not planning large future observatories such as the presently orbiting Terra, Aqua, and Aura platforms. Our plan and timetable for implementing the Decadal Survey. Our selection of Earth-observing missions to be flown in the next 10 to 15 years is guided by the Decadal Survey's science priorities. We take the Decadal Survey's recommendations seriously. Indeed, the 08 budget request addresses the flight recommendations of the NRC's 2005 interim report by including funding for the key precursor missions highlighted in that report. Now, the final Decadal Survey arrived too late to influence the FY 08 budget, but its recommendations are being used in development of the FY 09 budget request. Since the survey came out in early 2007, we've been vigorously pursuing activities in 4 areas. First, we've undertaken studies of each of the recommended missions to understand in detail the technical challenges and full costs, including the science, so that we can assemble and implement a realistic program. We're conducting community workshops to understand the capabilities of the missions as recommended, to optimize the intended scientific return, and to define the other measurements that must be acquired in order for the scientific goals to be achieved. The first of these workshops, which is focused on ICESat-2, is actually happening this week as we speak near BWI. We've engaged our international partners. In the past 2 months alone, I have had 8 productive discussions, multi-day, with partner space agencies in order to identify common interests and complementary expertise so that we can implement the Decadal Survey in a coordinated way. We're establishing joint working groups for future mission collaboration studies with the French, Japanese, German, Canadian, and European space agencies, in all cases building on successful existing and past collaborations. NASA is also playing a leading role in supporting the International Committee on Earth Observing Satellites, CEOS, which coordinates satellite systems for the International Group on Earth Observations, GEO. Finally, as planned, we're revising the Earth Science Division chapter in the SMD Science Plan to reflect the missions and the scientific priorities identified in the Decadal Survey. This revision will be reviewed by the NRC and the Advisory Council in the early fall timeframe. Finally, research to operations, transitions, and applications. NASA is working closely with other federal agencies, in particular NOAA and USGS, to transition research capabilities to long-term operations as the technologies are demonstrated. We've prepared the first NASA NOAA report highlighting our FY08 Joint Activity Plan as required by the 05 NASA Authorization Act. NASA and NOAA, working with OSTP, are conducting joint studies of the impacts and mitigation strategies in response to the Nunn-McCurdy refocusing of the NPOS program. The Applied Sciences program accelerates the broader use of NASA Earth science research results by partnering with other organizations in pilot projects to demonstrate how NASA results can improve decision-making and resource management. In many cases, the demonstrated improvements continue to be used by our partners even after the NASA Applied Sciences project ends. And we can talk about specific examples of that. We have identified an applied sciences representative for each Earth science mission in operation and in development in order to assure rapid and efficient identification of applications potential. So in summary, it will require several budget cycles to implement a program derived from the Decadal Survey's thoughtful and comprehensive recommendations. I would like to close by deeply thanking the Decadal Survey committee members. NASA's commitment to Earth science research is commensurate with theirs. Thank you.
Thank you, Dr. Freilich. Dr. Anthes, the floor is yours. Dr. Anthes, if you would turn on your microphone and...
Hello?
Much better. Thank you.
Okay. Mr. Chairman, Ranking Minority Member, and members of the committee, thank you for inviting me to testify today. As Mr. Udall said, I am president of UCAR, the University Corporation for Atmospheric Research, and I have to be careful because the gentleman to my left is going to be probably the next chairman of the UCAR Board of Trustees, and so I have to be nice to him and to the state of Texas during the presentation. Before I get into my prepared remarks, I'd just like to remind us that the news of the last few days about the terrible fires in Lake Tahoe area, following a winter of only about 30% normal snowfall there, the droughts in the west, the droughts in the southeast, where some places in Florida and Georgia are 12 feet below normal in rainfall, is all consistent with the kind of changes that we're worried about as the climate warms in the United States and the rest of the world. And so the observations that we're talking about in the Decadal Survey, as we said, are more important than ever, and this is not the time to be cutting back on observations of the Earth. It's the time to be augmenting them. The NRC report recommends a path forward that establishes U.S. leadership in Earth science and applications and averts the potential collapse of the U.S. system of environmental satellites. This can be accomplished in a fiscally responsible manner at a cost that is very small in comparison to the societal needs and benefits. Mr. Chairman, you asked me for my views on the top 3 priorities for NASA Earth science programs over the next 5 years. The highest priority is that NASA commit to and begin to implement its recommended decadal missions. Starts on the initial 7 missions should begin in 2008. Second priority is that NASA increase its suborbital capabilities. NASA's airborne programs have suffered substantial diminution and should be restored. Both conventional and unmanned aircraft are needed for instrument development, technology advancement, and for their direct contribution to Earth observations. The third priority is that NASA restores support of its research and analysis programs and efforts in Earth system modeling. Improved information about potential future changes in climate, weather, and other environmental conditions will come from better observations, but also more capable models of the Earth system and a vigorous research program to use the observations in models and interpret the results. This committee's leadership on Earth sciences and the recent actions in the House appropriations process with respect to the FY08 budget are encouraging and greatly appreciated. But even with the increase in the NASA Earth Science request for FY08, funding falls short of what is needed to get a full start on the recommended program, as you can see by this visual, which shows the actual NASA budget starting in 1996, going through the actual budget in 06 and 07, and then the projected budget or requested budget in 2008 and the run out beyond that. You can see that despite the encouraging upward turn for 2008, the gap between what is needed to complete and execute our decadal survey, and what's in the runout from the '08 request increases every year. The other point to make from this graph is that the funds to implement the decadal survey are only restoring the NASA Earth Science budget in real purchasing power to what it was in the last part of the previous century and the early part of this one. So we did a very strong prioritization to get a recommended set of missions that we considered minimal to meet the needs and not one that would bust the budget. You also asked about international partnerships, and Dr. Freilich made some very encouraging remarks in that direction a few minutes ago. I'd like to mention, of course, that collaborations with other nations not only save scarce resources for all partners, they promote scientific collaboration and sharing of ideas among the many talented people of all nations. However, they can come at a cost. The success of a partnership depends on both partners meeting their commitments, and if one partner runs into funding problems or technological difficulties, it can threaten the whole mission. I'd like to close my testimony with a quote from Vice Admiral Richard H. Truly, former NASA administrator, shuttle astronaut, and the first commander of the Naval Space Command, in a recent report, National Security and the Threat of Climate Change. Describing his experience in space 25 years ago, Admiral Truly said, "I have images burned in my mind that will never go away, images of the Earth and its fragility. I was a test pilot. I was an aviator. I was not an environmentalist." When you look at the Earth's horizon, you see an incredibly beautiful but very thin line. That thin line is our atmosphere, and the real fragility of our atmosphere is that there's so little of it. The stresses that climate change will put on our national security will be different from any we've ever dealt with in the past. For one thing, unlike the challenges we are used to dealing with, these will come upon us extremely slowly, but come they will, and they will be grinding and inexorable. Admiral Truly said he was not convinced of the importance of climate change by any person or interest group. He was convinced by the data. We as a nation must continue to provide the data on Earth, for only the data can reveal the truth that will affect us all. Thank you very much.
Thank you, Dr. Anthes. Dr. Barron?
Mr. Chairman, members of the subcommittee, thank you for allowing me to testify today. I believe we have one key goal, and that is to simultaneously protect life and property, promote economic vitality, and at the same time enable environmental stewardship. Achieving that balance is quite a challenge. And at a minimum, to be successful, we have to do two things. We have to know what components of the Earth system are changing and how they are changing, and an ability to separate out the human activity from the natural forces. And we need to be able to do a better job of anticipating or predicting the future. It's our ability to anticipate the future that makes knowledge about the Earth so powerful. Our scientific community is very appreciative of the actions taken by Congress at the start of the FY08 appropriations process, as you and your colleagues make real efforts to strengthen the NASA Earth Sciences program. Unfortunately, the FY 2008 budget request and its out-year projections are just not adequate. Under that current funding and projections, the U.S. will have significant gaps in long-term observations, making it much more difficult to separate out natural and human contributions to climate change, and making it much more difficult to assess how the Earth is changing. It's equivalent to knowing that we're having an intense debate for policymakers on the importance of solar versus greenhouse gases, and so now let's break this record so that it becomes even more challenging to answer that question. Under current funding and projections, the key areas of uncertainty, climate models, this ability to anticipate the future so we can put knowledge to good use, will likely continue to languish. I would also like to stress the fact that the decadal survey seeks primarily to ensure a reasonable and robust set of observations within a tractable budget, where tractable is defined as only restoring the budget to its 2001 level in terms of real dollars, while ensuring that the most critical observations, and certainly not all that are needed, are addressed. For climate studies, The list provided in the decadal survey is truly a base set. Each element is critical, and the list is not sufficient to address all the major uncertainties in forecasting the future. First, the decadal survey seeks to sustain the multi-decadal global measurements of key climate variabilities in order to understand how the Earth is changing, to understand the roles of natural versus human forcing, and to assess and improve climate models. The list is really a list of fundamentals: the input of energy from the sun, the Earth's energy budget, the atmospheric temperature and water vapor, sea surface temperatures, sea surface height, the distribution of snow and ice, ozone profiles, aerosols, and surface winds. It is truly a basic set of variables to try to describe how our climate system is changing. Second, the decadal survey seeks to tackle a key issue: the mass balance and stability of the large ice caps. The decadal survey places a high priority on determining ice sheet volume, sea ice thickness, ice sheet surface velocities, and improved estimates of the sensitivity of ice sheets to change. This is an area of great sensitivity in the climate system, and a huge question we have in front of us is how stable are those ice sheets. Third, the decadal survey calls for a focus on the two areas that are considered to be the most limiting in terms of our ability to improve climate model predictions. The first area is aerosol cloud forcing. It's one of the great remaining uncertainties in climate models. The second area addresses key uncertainties in the ocean circulation, ocean heat, storage and uptake, and ocean climate forcing. If we fail to implement the decadal survey recommendations, we will have an observing system and a NASA research program that is much less capable than the one we have at the start of this century. The impact on our knowledge base could also be profound. It may be a much longer-term impact than we realize. It's interesting to note that these climate issues are becoming increasingly important to the public, and I believe the demand for information from the public will begin to grow. This is occurring at a time where we have considerable weakness in the observation program, the research and analysis program, and it's occurring at the same time in which much of the NASA workforce is eligible to retire. And if you don't have those opportunities, you're not going to entrain the next generation workforce. And so we have the potential to be doing very long-term damage to the earth sciences by having this delay. Thank you for your time, and I welcome any questions.
Thank you very much, Dr. Barron. Dr. Foresman.
Thank you, Mr. Chairman, ranking members, and members of the subcommittee. I would like to focus this committee's attention on applications to what I feel is the foremost critical arena for carrying forth the NASA Earth Science Application Program mission for translation and engagement with the greater user community in our society. I'm specifically referring to a 1999 initiative that existed among 17 federal agencies called Digital Earth, which was led by NASA Earth Sciences. These agencies formed a common objective to apply web-based visualization technologies to enable data exchange among the various government departments. Interoperability of our government's information resources is a requisite step to addressing major decision support challenges facing our nation at local and state levels across a litany of compelling issues ranging from disaster warning and response to climate change research. NASA was leading 17 federal agencies in 1999 to create virtual three-dimensional digital Earth geobrowsers, today's Google Earth. NASA was also leading the design of the underlying architecture to operate and interconnect these systems with Earth observation, science data, and application. The potential prowess of these technologies to display and share data and information was not lost upon our federal colleagues. They fully recognized that these astonishing digital Earth capabilities would enable scientists and managers within our government to take full command of their own agency's information, resources, and interlink with all other information available throughout the federal government. Our industry and academic colleagues were quick to join with this engaging and visually enabled, captivating initiative for web-based collaboration. And indeed, many have continued to pursue this Digital Earth vision long after NASA began to decommission the Interagency Working Group. This decommissioning was unfortunate in my opinion. The loss of NASA's leadership, guidance, and momentum for the Digital Earth Initiative has proven to be a tremendous setback for critical areas in the Earth observation science program. The fact that geo-browsers such as Google Earth and Microsoft's Virtual Earth and many others can be directly linked to the Digital Earth legacy is testimony to the paramount importance of these technologies for their capacity to deliver science and information directly to the user community. And this is only the tip of the iceberg. 7 years later, NASA cannot deliver a decisive decision support system or a citizen alert system with anything resembling the ease of use and sophistication of Google Earth. While working for the United Nations Environment Program, I launched Google Earth's first contract in 2001, when they were known as Keyhole. Where was NASA leading us in 2001? What is the NASA's Earth Science Application Program doing today to build real-world partnerships that can quickly create visualization solutions for complex problems? What is NASA doing to fully engage with these geo-browser technology teams to rapidly move forth on delivering Earth observation science and information to citizens and decision makers? Market forces and free enterprise should not be allowed to replace NASA and its mission during our current era of global change and climate variability. This is why I am most concerned that NASA's Earth Science Application Program seriously rethinks its current trajectory and seriously engages with the creative forces of market and academia and NGOs. But most important, NASA should seriously accept and assume the leadership role that it once held in this most fecund and catalytic domain of science and technology, and apply this for the service of America and the world's citizens. When NASA declined to lead the Digital Earth Initiative, the Chinese were happy to leap to the forefront during the last 7 years and launched a series of international symposia, an international journal, and the International Society for Digital Earth. An incredible range of phenomenal and societal shifting applications are currently underway applying Digital Earth technology, including monitoring of Darfur human rights violations and conflicts, citizens' engagement with mountaintop removal issues in Appalachia, Yukon indigenous tribes assuming governance along the Yukon River Valley, grassroots women's groups creating peace maps for their community, and disaster response in Indonesia and Katrina. A small team at NASA Ames has developed a world-class and free open-source Digital Earth geobrowser called Whirlwind. The Whirlwind team, about the same size as Google's Earth staff was back in 2001, has been struggling for funding and needs support. Private discussions ongoing between Google executives and Director Griffin regarding strategic goals and objectives of the Google-NASA Enterprise Partnership should immediately be reviewed and considered by your committee. Rapid and collective action will be required to align NASA's Earth Science Application Program with the pace of development and action occurring in today's technology, science, and social landscape. Google Earth is just 2 years old. My team helped form and influence that trajectory for success 6 years ago. What can we expect of NASA over this next year? Thank you, Mr. Chairman, ranking members, and members of the committee.
Thank you, Dr. Foresman. I thank the panel for a very compelling and stimulating set of testimony. We'll now open our first round of questions. The chair will recognize himself for 5 minutes. I wanted to turn to Dr. Anthes and Dr. Barron initially. Dr. Freilich's testimony asserts that NASA's budget request supports a balanced program. Do you agree based on the recommendations of the decadal survey? And if not, what aspects of the program are out of balance? Dr. Anthes, why don't we start with you?
Yes, I would not say that it's not balanced, but it's just not enough. You can see that the purchasing power or the investments in earth science at NASA has decreased by 30% since the 2001 levels, and that is not enough to do even the minimal program that we're talking about. So I think it's more of a question of too little rather than not a balance.
Dr. Barron.
I completely agree.
And Dr.
I thank my colleagues for recognizing the balance in the program. I point out that we are flying 14 satellites now, and we have 7 more in development that will launch off by 2013. The size of the Earth science budget is itself determined from a series of balance calculations across the disciplines in NASA and between NASA and other agencies. It's my job to get the best science, the best applications from the resources that are made available.
excuse me, I think we may, thank you for that succinct and to the point set of answers. I think we may turn back to this at some point later in the hearing. I do want to turn to NPOs, Dr. Freilich, and talk a bit about the status of the strategies to mitigate the impact of removing the climate sensors from NPOs, and maybe I'll leave that as an open-ended question to you and ask you to respond.
Okay, thank you. As you know, it was just about a year ago when, because of a series of technical and budgetary issues, the NPOS program was refocused on its core weather forecasting objectives. And that resulted in the demanifestation of several climate sensors and the degradation of some others, which are important for the nation's scientific and applications programs. Almost immediately after that, and before I joined NASA at headquarters, NASA and NOAA, working together with the Office of Science and Technology Policy, began an in-depth study of the climate impact of those demanifestations and degradations. And that was presented in early January. And we ranked from that the top measurements that were required to be remanifested based on science issues. And you're well aware of that. And we are moving forward towards that. Subsequently, we have been working with NOAA and OSTP in order to develop mitigation scenarios and associated costs, and this is a work in progress still, in order to get those capabilities back in a realistic schedule, realistic budgetary environment, and addressing the science and the applications. In April, NASA and NOAA got together and jointly funded the remanifestation of the ozone limb system on the NPOS preparatory project. So, to sum up, we are working very, very closely and very intensely with NOAA under OSTP guidance to understand the impacts of the Nunn-McCurdy refocusing and to develop scenarios to regain those capabilities.
Could I ask more specifically, what are your plans for maintaining the teams developing the climate instruments, such as the TSIS, as you do the work to find mitigation strategies and the way forward?
In the area of, for instance, in the area of total solar irradiance measurements, the GLORY mission, which will be launching late in 2008 or early 2009, is primarily an aerosol mission, but it also includes a total solar irradiance monitor, which will continue that time series, which is critical to have on-orbit overlap. So in many instances, some of the measurements and missions that we have under development now will continue and extend those time series, and those teams are in part participating in the development of those missions.
Thank you. My time's expired. I now am pleased to recognize Mr. Feeney for 5 minutes.
Well, thank you, Mr. Chairman. Dr. Anthes, Barron, and Foresman, you've heard Dr. Freilich's testimony about NASA's approach going forward. Given the fact that we have some limited resources and there are constraints that all three of you are concerned about, but given that reality, do you think that programmatically NASA is taking the appropriate steps, and do you have any guidance for NASA, again, given the reality of the limited resources that you've pointed out? Dr. Anthes, why don't you start?
Well, I think we've given NASA about all the guidance that they need at the moment through the decadal survey. That was a 2.5-year study by over 100 people. But again, I get back to the point that NASA is doing a good job with what they have, but they just don't have enough. And we're talking about just going back to the 2001-2002 level. That's $2 per person per year in the United States. That's the price of a kind of a bad cup of coffee. And so I think this is affordable. I mean, this is not an unreasonable request to ask for NASA to ask the administration, or the administration to ask Congress, or Congress to supply the resources needed to do our minimal recommended program.
I would like to just add to that I think we have to find a way to fix this issue of climate continuity of these observations so that every single time it's not a stopgap effort. There were a large number of reports and a large amount of effort that suggested that NPOS was going to present problems for climate quality observations. And it's as if each time your worst nightmare arrives one more time, and you go through this, and even in writing the decadal survey, it was like a moving target to watch things dropping off and questioning what was going to happen and how it was going to be done. And now we are going to add studies. We're going to take a solar measurement that gets us part of it, but not everything. Each one of these components in terms of this record will be examined, but nowhere in there, I think, is the sense that we're actually going to fix this so that we can actually sit here and argue about how we're going to make improvements and advances, how we might be able to save money through efficiencies, how we might be able to do a better job of designing an observing system, because instead, the most basic and fundamental set of observations for the climate system are in jeopardy one more time. And so I think that a lot of analysis on how to maintain parts of that is not the issue. We have a bigger issue to fix.
Dr. Foresman.
Sorry, didn't push hard enough. Thank you. I certainly agree with their comments. I would relate mine to the other 95% of the community outside the scientific domain, in terms of I feel that NASA could do much better in terms of being able to connect and outreach with innovation, industry partnerships, academic partnerships, and NGO partnerships that heretofore have not been made available. But again, as I emphasize, the technologies that are now changing the landscape are but 2 years old, and NASA's not prepared within their staff and experience at the current time to address how that strategically impacts what they should be doing to deliver to every district in this nation and the citizens that lie within there. Thank you.
Well, Dr. Freilich, given Dr. Barron's point about the continuity of some of the programs, there is a risk that some of our current satellites that are operating well past their design years may expire before replacements are launched. How serious would the consequences of a data gap for a year or two be in terms of our mission, and talk about the risks of calibrating new sensors in terms of that continuity that Dr. Barron was concerned about?
I could deliver a lengthy treatise, as my academic background is asking me to do, but I'll refrain from that for your benefit. In the need for continuity and the approaches to calibration and validation, either on-orbit overlap or vicarious calibration, differ from quantity to quantity and measurement to measurement. Let me focus, for illustrative example, on total solar irradiance. We have a 23-year plus time series of measurements of the sun's output, broadband. We can make very, very stable and very sensitive instruments, but we can't absolutely calibrate them on the ground. Therefore, it's essential for that measurement that we have on-orbit overlap of 6 to 12 months so that the time series can be made consistent and we can understand whether changes are owing to the changes in the sun or changes in the instrument when we weren't measuring. And therefore, for instance, that's why we have put a total solar irradiance monitor on the GLORY mission, which is due to launch in late 2008 or early 2009 to assure overlap with our existing instruments, for instance, SOURCE. Consistency and continuity, where our understanding and our predictions are sensitive to it, is number one on our list, because it's essential for us to redeem the nation's previous investment in these time series by continuing them where necessary. In some other areas, we could survive with a gap or a degradation and do calibration using transfer standards.
Mr. Chairman, my time's expired, but if the chairman would agree, I would just like to get Dr. Barron to respond to that, because it is a concern that you raised, and you think that is what do you think of Dr. Freilich's response?
He's provided a good answer, and it is true that different rules and needs apply for different sensors. But if you can imagine for me a minute of having a system in which we say, oh, we're about to lose this because it didn't work here, let's go do something over here. Or if something fails and then make a decision that you're going to do something, that's not a very robust system. And we've been arguing about how robust this system is and what it needs to be done to make it more robust for at least 20 years, it seems to me. And it strikes me that we're in worse shape, not in better shape, in terms of designing that as a system. So I agree that what he said is correct, but I do not think that embodies a strategy of how to put this problem aside so that you're not continually readdressing what you need to do and what you need to add because you've lost something here or there.
Thank you, Dr. Barron, Dr. Freilich. We'll now recognize the gentleman from Texas, Mr. Lamson, for 5 minutes.
Thank you, Mr. Chairman. I think I share some of the frustrations that all of our colleagues may be starting to express more and more. And Dr. Anthes, I think I would have probably not said nearly as nicely as what you did about resources. We keep hearing time and time again the comments that NASA and other agencies as well will make the best efforts possible with the resources available. I think that's a huge cop-out. And that there are budgetary issues, there are, but we're teaching this nation to not understand about science. We're teaching this nation that we're not going to get a return if we invest in something that will tell us something about our future. And the return is huge. And I was sitting here thinking that this little statement behind me, how indeed true that it is, and that if we don't step up to the plate and exhibit the political will and quit copping out to those who are leading us without that vision. We can talk words of vision, but we have to implement it, act on it, and I think there's an interest on the part of our Congress to do that. We need guidance, and we need guidance from the science community. We need guidance from this public, and the public itself needs to be taught, I believe, how to respond to us so that we can become the followers of them and hopefully put the resources where we need. I'm going to try to ask a whole bunch of questions in a very short period of time, so short answers, please, gentlemen. Dr. Freilich, the Earth Sciences Decadal Survey discusses the need for transitioning research satellites and measurements into operational systems. The NASA Authorization Act of 2005 calls for NASA-NOAA coordination on research to operations. How often has NASA-NOAA joint working group met? And when was the most recent meeting?
The Joint Working Group, which is one of many specific groups, met twice during 2006, and I believe that the most recent meeting was in April of 2006. It was a multi-day workshop. However, there are many other meetings periodically that we have and regularly. There's a tri-agency altimeter working group, and as I pointed out, NASA and NOAA have gotten together and remanifested the OMPS LIM sensor on NPP
Bottom line
demonstration.
This committee's met, though, a year and a half ago, almost. What specific issues has it addressed?
The Joint Working Group has 5 specific issues that it addresses, and it focuses on transition of measurements, transition of missions that are on orbit, and issues associated with data set, stewardship, and climate records.
Is the Joint Working Group with NOAA able to effectively plan for transitions from research to operations?
We face a real challenge as a country in doing that transition. There have been very few successful and rapid transitions. However, with guidance from the National Research Council, and Dr. Anthes, in fact, authored the Contro report, the Committee on NASA-NOAA Transition from Research to Operations. People at NASA and at NOAA are very sensitive. The Research Council has set out a path forward, and the Joint Working Group and the other working groups are leading us along that path. We are making progress.
Would any of the other witnesses care to comment on any of those questions?
It's a really good question. It's a very tough problem, this transition research to operations. I hate to keep whining about not enough resources, but, you know, it takes resources to transition these new technologies into NOAA operations. And NOAA's budget's been relatively flat, even declining, and they simply don't have the resources to transition even the simplest, even some of the cheapest new technologies into operations. So this is really a big issue, as Dr. Freilich says. And we just have to come to grips with there is no plan, there is no national plan, it's not going well. Partly it's due to the fact that NOAA doesn't have the resources to take on these responsibilities, and so it's not just simply a one-agency problem, it is a two-agency problem.
The yellow light's on. If I start into this, it's going to take me a few more minutes. So I'll yield back my time now. And
well, if you have no objection, go ahead.
Yeah, Mr. Lamson, why don't you take a couple more minutes?
Thank you very much. For Dr. Anthes and Dr. Barron, according to a recent article, scientists exploring options for QuickScat success in Space News, the new director of the National Hurricane Center has emphasized the need to plan for a replacement to NASA's QuickSat satellite should it fail. The Decadal survey proposes a follow-on to QuickSat, but not until 2013 at the earliest. What's the reason for the timing of the Extended Ocean Vector Winds mission, XOVWM, and how urgent do you believe the situation with QuickSat is?
I think you see that what the Decadal survey did was put a whole group of very important missions on the table, and at the same time we tried to live within a very specific budget constraint, which wasn't give us more, give us more, give us more. It was get us back to where we were in 2001 and 2002. Now, you only have one choice there. You have put a list there, but you have to put them in time, in some sequence. And so you'll see that one particular mission that focuses on one critical topic is delayed till a later date because of hope that something will continue, or because something else in another part of the world is going to contribute some information. But there really was, within that envelope, no choice. And I think what you see, too, is there's nothing added to that in terms of true innovations on that list. It is just basically to fit things in as best we could that were critical. At least that's my view.
I can only add a little bit to that. There is a European scatterometer in place now called ASCAT, which, although not providing the level of accuracy and that some people would wish, at least is an interim scatterometer that will provide some of the information needed for the ocean vector winds that are important for hurricane forecasting.
And we're also going to rely on the Russians for our moving our men and women to and from the International Space Station, and who else are we going to be relying on into the future? What advances would the XOVWM mission offer over the QuickSat? And I'm going to ask Dr. Freilich
This is your
to comment
field.
afterwards.
He's an expert in scatterometry, so I should.
I'm very proud of QuickSat. I was the mission principal investigator for it, and so allow me. The XOVWM mission that was recommended by the Decadal survey primarily has higher resolution in space, so it measures more fine, short-scale variations in the wind field, and it will have the ability to make measurements that are accurate under raining and severe conditions which present systems cannot do. So we'll be able to get closer to the coast, we'll be able to measure smaller scale wind variations when the NOAA XOVWM mission flies, and we will be able to make measurements that are accurate under extreme conditions in rain.
My last thing, and it's short, and I appreciate the indulgence of the chairman and ranking member. I sent a letter regarding the NASA NOAA Research to Operations Working Group report. It was asking for that. It was supposed to have been here on February the 15th. NASA sent it for clearance, I think, earlier this month. Do you have any idea when I might be able to expect delivery of that?
I'm relatively new to the federal government, and I'm learning a lot. I can tell you that that substantive work on the text of that report ended many weeks ago, and it is working its way through the agency and interagency review process. We'll take an action to get back on you. I think that it's imminent, but I can't say with certainty. I'm sorry.
My fear is that we have become such almost a bloated bureaucracy that we can't move. And somehow, I think as some of you have stated, Dr. Foresman and others, we've got to find a way around that. We've got too much at stake for our future. Thank you, Mr. Chairman.
Thank you, Mr. Lamson. That was a very important line of questioning. And Dr. Freilich, I hope that you will respond to Dr. Lamson, or Mr. Lamson, as soon as possible. He does. There's a Dr. Lamson. It turns out it's Nick's brother. If I could, Dr. Freilich, I want to go back to discussion of climate instrument teams, and it's my understanding that the GLORY instrument contracts are winding down, as important as that project and set of projects is. What specifically will NASA be doing to maintain the TSIS team for the remainder of '07, fiscal year '07, and through 2008, while OSTP is deciding what to do?
I can't give you any specifics, sir, beyond the fact that although the contracts, or although the development work on those instruments, that instrument is in fact winding down because the instrument is being built and successfully delivered and integrated. There still remains a lot of work for integration, test, and maintenance of that, followed by, of course, after launch, the validation and calibration and characterization of the instrument. I don't have the specific information that I can give you on TSIS. Again, we can find that.
You have an idea when you might have that specific information?
As soon as I can get back, and within a couple of days, I will make inquiries. I'm sorry.
That's terrific. Thank you. Let me continue on the TSIS line of questioning in the context of some broader concerns. NASA officials have indicated that the Landsat continuity mission is being considered as a potential platform for TSIS. And how about a sense of when a decision might be made on that option? And how would adding the TSIS affect the LDCM schedule and the duration of any potential gaps in the land cover data record?
You've hit the high points, Mr. Chairman. You're well informed. The Landsat data continuity mission is designed principally to extend the 30-year plus record that we have of moderate resolution radiometry over and imagery of land surfaces. It's been an incredibly valuable data set. At present, we have two spacecraft, both flying well beyond their baseline lifetime. LDCM is scheduled for launch at present in mid-2011, designed specifically to minimize the gap, and we're afraid that we will have a 6 to 12-month gap in that long time series. We are looking at using that platform potentially, as you said, to extend some other critical time series, such as TSIS. The number one issue that is guiding us there is, in fact, the schedule and the risk for minimizing the gap on the time series of the land imagery. We are looking at lots of options, and again, that work is deeply underway and has been for several months. We are letting 4 contracts for LDCM, and they are in the process of being advertised and let right now, and the interaction between them and the technical addition of TSIS will govern our schedules and our decisions.
Let me follow on here. What role, if any, will the decadal survey missions have in addressing any potential gaps in climate and environmental measurements as a result of the Nunn-McCurdy restructuring NPOs?
If I understand your question, it is, can decadal survey missions fill in for potential NPOs demanifestations? Do I have that correct?
That's fair enough.
Okay. The decadal survey actually was, as Dr. Anthes and Dr. Barron said, was very careful in not overlapping capabilities for the nation. So, in fact, the problem turns out to be almost an opposite one. That is, the NPOs refocusing happened late in the decadal survey process, and many of the decadal survey missions actually rely on measurements that were to be taken by NPOs as opposed to duplicate measurements that would be taken by NPOs. And one of the goals of our workshops is to actually understand what contextual measurements that would have been made by NPOs are necessary for the decadal survey science so that we will advance the science.
Perhaps I could just take another minute and ask Dr. Anthes or Dr. Barron if they cared to comment on the last question.
Well, there were 2 recommendations for NOAA in the very early time frame, the 2010 to 2013, that have great bearing on climate. One is the Clario mission, which is to do benchmark climate radiation observations. The climate fundamentally is warming because there's an imbalance between what the radiation we're receiving from the sun and what's being either reflected back or emitted back. And so we need a set of benchmark radiation observations that will measure not only what the sun is putting in, but what's being reflected back and what's being emitted back from the Earth. The other instrument that's recommended in this very early time frame is the GPS radio occultation measurements, which make very accurate and precise measurements of the temperature and water vapor structure of the atmosphere. Again, these would be benchmark climate observations that will tell us how fast the atmosphere is warming up, where it's warming up the fastest, and how the water vapor is increasing regionally and globally. So these are 2 relatively inexpensive missions that can be launched by 2010 and will contribute to the very essential climate observations.
Dr. Barron, anything else to add?
Those I completely agree with Dr. Anthes. Those are extremely important, and I would also, like to confirm what Dr. Freilich said. As chair of the climate panel, we sat there with an assumption that we had a basic set of observations, long planned through NPOs, that would continue, and that our objective was to build upon that. Where are the great uncertainties in climate models? How can we make observations to make improvements? And in particular, in the latter half of the decadal survey, every meeting of my panel, it seemed we had to reassess what was the base that we were building upon, because we were moving from a situation of, instead of proposing innovative ideas to tackle important problems, we were trying to make sure we were going to not lose what we've had for decades.
Thank you, and Mr. Feeney's recognized.
Well, thank you, Mr. Chairman. Congressman Lamson raised the international reliance and cooperation issue. Dr. Freilich, obviously there are some advantages, including avoiding duplication, services and reducing costs with cooperation. Your statement suggests that there are some bilateral discussions underway with several partner agencies. Is the concept to have other countries assume full responsibility for designing, building, and operating individual missions, and then sharing the data, or to have one or several partners participate in individual missions, or is it a combination? I guess it'd be helpful to, see where we're going with the bilateral agreements.
Excellent point. The answer is it's a combination. First, let me say that the Decadal Survey very specifically points out the need to leverage our capabilities with those of our international partners. It points out that the scope of the problem and the scope of the solution is far greater than what any single agency or any single country can do. It turns out that our Decadal Survey scientists are completely in line and leading, in fact, the global climate science and Earth system science community. So our aims in NASA are well aligned with the aims of our partner agencies, in other countries. Having said that, in many of our discussions, we are talking about contributions from an instrument standpoint from multiple countries to a particular mission, but we are also spending extra amounts of time to talk about trading missions. If a mission can be flown from a particular country and the data are freely available and well characterized, then it aids everybody in our analyses, and therefore we don't have to duplicate those measurements simply to say that we were making them as well. The resources are limited, the problem scope is large, and we really have to have unique application of our resources, not duplicative. Having said that, we're trying all possible permutations.
And as you enter and participate in these negotiations, how will ITAR regulations hinder or impede your efforts?
ITAR presents challenges. We conform with the ITAR regulations, and I am intimately familiar with several international collaborations. Like I say, ITAR presents challenges, but we can surmount them. We are going to be flying, for instance, we have altimeter missions joint with the French agency CNES that have been very successful, and we'll be launching OSTM in June of 2008. We'll be flying the first ever sea surface salinity measurement mission with our Argentine colleagues, Space Agency CONAI, and that'll be launching in the 2009 time frame as presently listed. So ITAR is challenging, but it can be surmounted, and we do obey the ITAR regulations.
And finally, Dr. Anthes, you've mentioned some of the international cooperation components to accomplishing the overall goals. What do you think with respect to ITAR and the potential hindrance it poses?
Dr. Freilich said they can be significant, and then some kinds of technologies they can actually prevent international collaboration. The international collaboration, as I said, we have to consider that carefully. But at some point, I think, as Mr. Lamson implied, the United States can't rely entirely on other nations to make these critical observations. It'd be a little bit like having a military that relied on international partnerships. We certainly need to do some partnerships, but I think that some of these key observations, we cannot assume that these partnerships will be there and will be successful.
Thank you. Appreciate everybody's testimony, and yield back my time.
Mr. Lamson.
Thank you, Mr. Chairman. We also have to be real cautious, I believe, with our international partners when we enter into arrangements. There seems to be more and more opportunity for us to find some way to renege on some of those. There's one that I have in mind that doesn't impact any of you, the AMS project, which is a $1.2 billion project that has been 95% paid for by international partners. And our promise was to put it on the space station, and at this point it is no longer on the manifest to be able to go to the space station. Those folks are not happy campers. And so if we expect to be able to enter into these arrangements, which I think are critically important, I don't see how there's any better way for us to build friendships than by working on things that benefit the people of both or more countries. We just have to be able to be cautious with what we do, what our plans are. I don't have a question in any of that. I think I started a rant a little while ago. I love NASA. I love the science agencies that we have in this nation, and I want to do the things that can bring attention to the magnificent accomplishments that they make and the people that have the bright minds that are making those, and to continue to be able to support them in a bigger and better way. I think it's important for us to point out that right now NASA has a budget that is 0.6% of the nation's budget, and in the 60s, when we were having magnificent achievement in education and in technological advances, the budget for NASA was 6% of our nation's budget. Significant difference in commitment, and that's something that I hope and pray that we can get back to as a Congress, as a nation, and as a scientific community. And with that, I yield back my time, Mr. Chairman.
Ms. Lamson, if I might ask you to yield, we could use a little bit of your time. I know we've had conversations about the AMS project and the important work that would be done on this very fascinating area of antimatter. And I think we have some opportunities in July to question NASA about their plans in this regard. And in general, I look forward to working with you to further understand why we can't see that this important project be undertaken. And I think you and I have some additional plans
Indeed.
to pursue this.
And I appreciate your interest in it, but I tried to mention that only to let it be a part of this big picture of what we're not doing right now. There are too many times when we take and make the excuse of we can't get the resources to do something. If it's important for us as a nation, as a people, we ought to find the resources. We did once before, and we got an unbelievable return for it. And that's what I'm looking for. That's what I want to see my government doing for this nation. It's within us. We've got to have the leadership to make it happen.
Well, I thank the gentleman for yielding to me, and I'd yield back to him if he...
And I'll yield my time back. Thank you, Mr. Chairman.
I thank the gentleman. Well, the chair will recognize himself for 5 minutes. I did want to return to Dr. Freilich, but also give Dr. Foresman a heads up that we haven't been ignoring him, and I wanted to give him an opportunity to comment on the question I'm going to ask Dr. Freilich. And what I want to focus on was the Academy's survey, the decadal survey, stressed the need for observation systems to look at both scientific and societal needs. And I want to just give you a chance to talk about how NASA's planning process for future Earth observation systems takes into account this important area of societal needs. And when you're finished, I'd like to give Dr. Foresman an opportunity to comment as well.
Our missions are the basis. They provide the hard measurements and the information. The Research and Analysis Program develops scientific-based understanding of the Earth as a system using modeling as well as those measurements. Our Applied Sciences Program serves as what I call a flexible bridge between the knowledge that we gain in the Research and Analysis Program and the need for focused information to address societal benefit areas. And very specifically, our Applied Sciences Program is designed to further that communication between the science understanding that's driven by the missions and the need for services and information by others who are dealing specifically with societal benefit areas. The focus of the Applied Sciences Program is becoming aligned with U.S. GEO, Group on Earth Observations, and their 9 societal benefit areas. In each one of those areas, we have pilot projects in which we demonstrate the utility of the NASA measurements and understanding to further other agency and other organizations' goals for their objectives. So, very specifically, the Applied Sciences program forms that connection between the science and the societal benefit areas. We're aligned with USGEO, and as I pointed out, we're playing a very key role in the International Committee on Earth Observing Satellites, which is the coordinating arm for the global GEO.
Thank you. And I want to turn to Dr. Foresman, and I think in particular ask Dr. Foresman to outline some examples of how this very powerful technology could be used. I had opportunity to hear recently, Dr. Foresman, a radio story about Darfur and how actually satellite imagery could help us understand on a real-time basis what was happening there and would help us expand our efforts to prevent what's clearly genocide and a very tragic situation from further developing. And I know you had some other examples in your testimony of how we...
Yes.
technology. So the floor is yours.
Thank you, Mr. Chairman. This also tends to reach into issues of international cooperation as well. So it's not just restricted to the U.S. But we're sitting at a profound point in history where we can view these various radical, if you will, changes in terms of land use or humanitarian issues around the planet that with regular citizens being able to engage. And this is something that the Applied Science program, again, with due respect, having been in that program, and I know they did a lot of very good things, but the bureaucratic realities tend to basically dilute the ability to provide rapid response. And the rapid response is occurring in a variety of sectors at a rate which we'll talk about into the hundreds of thousands of projects that are showing up around the planet that unfortunately is beyond the scope of NASA headquarters to address. However, by restructuring, they could have the potential to address this in some very significant ways. You know, we're looking at deforestation issues, while searching for better algorithms for carbon. Sometimes the academics spend time sequestering their information to be published while the forest has been removed, and so they come back and they find out that it's a moot point, and this happens continuously. Then reporting on how many trees are there and is a phenomenal area that we're still abjectly behind the ball. Recently, one of the applications was done in Santa Cruz, not known as a developing nation, but Santa Cruz, California, where they were able to save 1,000 redwood trees in the backyard simply by providing, through these various visualization tools that I'm speaking of, that NASA was the leader in, showing the community what was going on with 1,000 trees that had been promulgated through the official channels as but a clear a logging exercise by the water district. Well, it was a clear-cutting exercise to gain monetary benefit to a watershed district. This is a phenomenal thing, 1,000 acres of redwood trees right in the backyards of some of the most literate and intelligent people on the planet. So these kinds of examples are showing up, and we captured many of those in Berkeley with General Pete Warden, who was there in Berkeley just 2 weeks ago with me, highlighting many of these examples. And it was interesting because the Google executives admitted, and it wasn't just Google, you know, I don't have stock in that company, admitted that they can't even contain what's going on, that this is an uncontrolled experiment. Well, it's an experiment that NASA should be controlling as best they can, because it's the absolute soft spot. Is where the rubber meets the road in terms of how to transfer our science and knowledge into the backyards of citizens. And so we have a choice. There's two paths. We can sit back and say, well, it'll happen, and let's watch what happens. Or we can say, no, this is a time for leadership and to really gain the upper hand in these application areas, because they're so profound in terms of mountaintop removal for our energy resources, in our country, in terms of, as I say, governance by indigenous people that are taking over water quality monitoring and sampling from the USGS and EPA. in a very profound way, and a great example of the communities taking on the responsibility for stewardship in the backyards, and the tools are there now that we only dreamed of 7 and 8 years ago. They're here now, and they're not part of the plan. Thank you.
Dr. Barron, would you like to comment as well?
I would. I think it's an extremely important question, and to be perfectly blunt, I view the applications program side of NASA a decade ago as throwing data over the transom and finding out who might grab it. I view the current program as one which is directed throwing data over the transom, where you're sitting there looking at a particular application use and making sure that the data is available. But I think we forget the fact that there is actually a science that needs to be accomplished to make these societal connections. You're sitting right now in a world in which climate variability is having a big influence on something like West Nile virus delivered by a mosquito. Yet you're sitting there analyzing where and how to respond in hindsight by collecting numbers of dead birds and testing them. When we have the capability to actually couple the science and human health sciences together so that you actually start to forecast the outcomes for something like a dengue fever or a West Nile virus. We have that capability in a short term or a long term if we can put the communities together and to begin to set up the types of observations and modeling that you need to do it. And by collecting observations and sitting there thinking just as a climate scientist, you're not going to make that accomplishment. You actually have to bring these societal connections to the fore, and not one which is a handoff of data, but one that actually promotes scientific discovery and brings that same discipline of forecasting that we apply to weather forecasting to something like human health forecasting.
The two other committee members that are here inform me they have no additional questions. I did have one additional line of questioning I wanted to direct at the panel, and then we'll draw the hearing to a conclusion. And we'll turn back to Dr. Freilich, but I would like everybody else in the panel to feel free to comment. Your testimony indicates that NASA's plan for future Earth observing missions will integrate the scientific recommendations of the Decadal Survey, the ongoing NPOS, McCurdy changes, and the contributions of our international partners. That's no small task. Could you explain in specific terms how you plan to actually make that integrated approach a reality? And then if I could throw an additional two questions at you. What's the timeline for that integrated plan? And how does that timeline address any potential data gaps as a result of the restructuring, the non-McCurdy restructuring of NPOS?
You're correct.
If you want to provide some of this for the record, we'd be happy to indulge you in that way as well. But if you want to take a shot right now, I'd appreciate it.
Okay, I'll take a shot at that. Before I start that, may I have your leave to address the timeliness of some of our applied sciences projects?
Sure.
Or is that okay?
Please.
Okay. Dr. Foresman made a very good point about the need to be timely in order to actually have real benefit. And Dr. Barron talked about throwing directed or undirected data over the transom. We have some real shining stars of projects in the Applied Sciences program, and I'd just like to talk about two, or maybe one to start with. The Surveyor node, which is a an environmental monitoring, synthesizing, and distribution center that we in Applied Sciences have set up in Central America to bring in not only NASA data, but also models from other agencies, and to provide the information that's necessary for decision makers in the Mesoamerican area to actually manage the environment and understand. Just last month, I think it was around the 18th of May, we were contacted by the Environment Ministry of Honduras, where there was a degradation in air quality. And it was unclear whether this was being caused by Saharan dust. They knew that there was Saharan dust in the area, or whether it was being caused by smoke. And the response in Honduras and Nicaragua and Costa Rica would be quite different. In just a matter of 4 days, Surveyor took data from our flying satellites, including the relatively recently launched Calypso satellite, which measures aerosols and clouds, as well as data from MODIS, combined that information with models of smoke distribution, fire distribution, etc., many of which were generated in the U.S., and provided a clear description to the affected areas that, in fact, there was dust, but it was located well to the east in the Caribbean, and the degradation of air quality that they were seeing was resulting from fires, which were relatively local, at least to Central America. The point being that in that very short amount of time, that NASA-sponsored project could provide the specific information that was flexibly needed by that ministry. Okay, now let me answer your questions. Sorry about that. It is a big task to pull together the international collaborations, the NPOS response, and our increased understanding of the technical and cost challenges of the missions. We are working on a time scale that is focused on informing the FY09 process, because the administration's FY09 budget process is the first one that's going to be fully looking at the detailed recommendations of the decadal survey. I've been on the road almost constantly for the last couple of months, speaking with our international partners and bringing together some of those joint science working groups. We actually even started some of the concept studies to look at technical challenges and cost a little bit before the decadal survey came out. They have all reported to us once, and we are in the final stages of rationalizing those inputs. And it is our hope and you know what's happening with the NPOS, OSTP, NASA, NOAA joint deliberations. They're all focused on coming up with at least the outlines of a plan and the associated resources in order to inform the administration's development of the FY09 budget process. So we are moving towards a fall coalescence or synthesis for the integrated plan.
Dr. Anthes or Dr. Barron, did you have any interest in adding additional commentary to Freilich?
Well, I think it's good that they're seriously considering the decadal survey. But it's going to take more than rebalancing, more than considering, more than a few workshops. Mr. Lamson's right on. This country can afford this. We can't afford not to do it. There's a cost for doing nothing. We're talking about, some wag to stabilize greenhouse emissions in the United States might cost $30 billion. $30 billion, that's just annually. Is that going to work? How do we know that's happening? Are we going to invest $30 billion in something that won't work, or we can't observe or can't verify? What about China? China's the greatest greenhouse gas emissions country right now. How do we know what they're doing and whether what we do will make any difference compared to what they do? So the cost of doing nothing is huge. The cost of getting on with it, observing this planet, is very, very small. We just got to do it.
Thank you very, very much. Dr. Barron, you want to have the last word, or should we leave Rick with it? Well, thank you all today for taking your valuable time to appear before the subcommittee. We look forward to future visits on the part of all of you. At this point, I want to announce that there's no objection. The record will remain open for additional statements from members and for answers to any follow-up questions the subcommittee may ask of the witnesses. Without objection, so ordered. The hearing is now adjourned. Thanks, Tom.
Yeah, pleasure meeting you. Definitely. You had excellent description.